Hi and Assalamualaikum. We are from CS2485B3 and today we would like to present our group project which is line integral. Okay, these are our team members. Ismi Ashraf bin Salihuddin, Nur Sada binti Wan Osdi, myself Nur Sabarina binti Syaiful, and the last one is Wan Amira Amali binti Wan Azman. Next, I will begin the presentation with the introduction. Okay, what is line integral? Line integral is to integrate a function along a curve in a coordinate system using scalar valued or vector valued functions depending on the representation. For example, as in the diagram. Okay. The first formula is for the area is then found for fxy by solving the line integral. And the second formula is also for the area but generalized to three dimensions. Okay, the next one is line integrals over scalar functions. If f is continuous in a region D with curve C, parametrically described by xt, yt, and has continuous first derivatives. And this is the formula for scalar functions. However, in tree space, if f is continuous in a region D with curve C, parametrically described by xt, yt, zt, or rt, and this is the formula. The next one is line integrals over vector functions. And this is the formula for line integral for vector field arc length. Last but not least, work as a line integral. This is the formula determines forces work. Okay, next I will proceed with question 1. Question 1. Evaluate integrate f dr where fxy equals to negative 2y I plus 2x plus 1, j, and c be a curve represented by part of circle where x squared plus y squared equals to 4 from 0, negative 2 to 0, 2 as in the figure 1.
Next, I am going to explain the manual calculation for question 1. Firstly, we are going to find RT hence for circle equation x squared plus y squared equal to 4. We can get x equal to 2 cos t and y equal to 2 sin t. Therefore, RT will be 2 cos t I plus 2 sin t j, and the length is from negative pi over 2 to 2 pi over 2 because it is half circle on the right side. Then we differentiate RT will be negative 2 sin t I plus 2 cos t j. After that, we substitute x and y into fxy. Lastly, we do dot product of f with arc prime t and we integrate. The answer is 8 pi plus 4. Next, we move to mapper comment for question 1. Firstly, we use restart the comment, then we use vector calculus because we are going to use a dot product in the calculation. Next, we put comment with plots because we are going to plot the field using free plot and implicit plot. Then we insert the comment for equation of force field, which is fxy equal to negative 2y for component of vector I and 2x plus 1 for vector j. After we click the enter, the mapper will show f equal to negative 2 exponent x, where exponent x represent for vector I, and plus 2x plus 1 exponent y, where exponent y represent for vector j. Then we do field plot to show the flat movement that have been shown in this slide. Next, we do the implicit plot to show the graph of curves where represented by circle of x squared plus y squared equal to 4 from 0, negative 2 to 0, 2. Then we need to find RT for the given curve. After that, we need to differentiate RT with respect to t. Then we need to find the dot product of force field with the arc. We need to substitute x and y into the answer of dot product. Lastly, we calculate our work done by integrate the answer from negative pi over 2 to pi over 2. And finally, we get the answer where the work done is 8 pi plus 4.
Next, we move to the question 2. For question 2, let C be a curve described by C that vector r of t is equal to 2t square I minus 5j minus 1 over 2t square k for 1 less and equal to t less and equal to 2. Evaluate the integral vector f dot dr where vector f of xy is equal to x squared I minus 4yj. Now I will show you how we solve this problem manually. Step 1. Differentiate the vector r of t and we will get the r prime of t is equal to 4t0. Step 2. Substitute the value of r of t into the function f and we will get the 4t cubed 20. Step 3. We have to determine the dot product. So take the value from step 1, multiply with the value of step 2 and the answer we will get 16t to the power of 5. And the last step we need to calculate the integral vector f dot dr. Just integrate it like usual and at the final answer we will get 168.
Okay, Assalamualaikum and hi. Next, for the maple command, the first step is we need to use restart command and then we will call with vector calculus and with plot command so that we can use the mathematical symbol and plot the graph easily. State the equation that we want to use as the vector field, which is x squared and negative 4y. Next, we will try to plot the vector field using the common field plot and the graph will appear in the output from the command. Then, we need to parameterize the equation by putting the equation and we get the output which is 2t squared ex minus 5ey. Next, we find the derivative from the parameterized equation using the common diff and the output is 40ex. Then, substitute all the value we get from the parameterization into the equation of vector field and perform dot product in the maple using command dot product vector field dr and we will get the answer. And lastly, we will evaluate the answer and we get the final answer in the output which is 168. Okay, next for reference. Okay, this is our reference that we use to complete our group assignment. Okay, that's all for our presentation. Thank you for watching and bye.